The complexities that you'll run into when building a multiplayer game can vary greatly depending on your end goals. Are you creating a simple 2v2 match-based game using Steam, or are you embarking on building out the next big MMO that demands scaling to support hundreds, if not thousands of players? Either way, if you have no multiplayer experience, you have to start somewhere. That's the goal of this video, to be the primer into the world of Godot multiplayer development. This tutorial is split up into 6 major sections. Each one builds upon the previous section for a complete walkthrough towards a finished game. I'll put some chapter markers below. If you want to build along with the video, pull down the project link below. Open it up, and if you poke around for a minute, you'll notice I've got a few things started like the main menu and game scene. Hopefully that'll save us some time. However, I will say it may be a good idea to just watch the video once through before following along. I'm also assuming you have at least some basic Godot experience, and in order to stay focused on the multiplayer side of things, I'll likely breeze through some of the more trivial parts, and of course you'll have access to the finished project for future reference. Let's get started. So what do we want to build? I'm thinking a basic 1v1 multiplayer battle where each player controls a ship that can fly around the level. For combat, let's have the ships be able to shoot missiles and take damage when hit, which means we also need a health bar. I think I'll just keep it under the ship. And finally, I think we'll tally each time a player gets a kill, and the first 1 to 5 is the winner of that match. When you're starting out, the 2 big things you need to think about are, how do we establish a connection to enable multiplayer, and how do I send and receive data to bring the multiplayer world to life? The first point, establishing a connection, is fairly straightforward for this demo, but as your game's feature set expands, this becomes more complicated. Think lobby systems, matchmaking, hosting services, etc. But don't worry about that today. And to the second point, there are many ways to tackle this, and it's an ongoing process throughout the development of your multiplayer game, but for this project, we'll be using Godot's high-level multiplayer APIs. That means leveraging tools such as Multiplayer Spawner, Multiplayer Synchronizer, and RPCs to bring the game into action. Let's get started with establishing a connection and sending some data. Create a new branch, and we'll commit our changes at the end of each section. Let's begin by creating a new folder under scripts called Network. It would be helpful to have a network manager that is an auto load. So to create one of those, go to Project, Project Settings, Globals, and then enter the name Network Manager. Change the save path to the network folder you just created, and then hit Create and Close. Let's go ahead and open that up. An autoload is Godot's version of a singleton. These do not get destroyed when changing scenes. That feature will come in handy since we'll need to access networking code throughout the life of the game. So it's a good idea to use an autoload to organize this functionality. Fundamentally, all multiplayer begins with establishing some type of connection over which we can share data. Generally, a multiplayer connection consists of a server peer where other client peers can connect to. Maybe you've even heard of this. Ever hear someone say, join a server, host a game or game server? That's likely the same idea. For this project, we're going to create a server that acts as the host of the game, which also has an accompanying player. This is a common setup for multiplayer games, and recently, my good friend over at Pondersoft just released his first game, Bubble Battle, on Steam using this approach. So let's start by creating a new function called createServer. For this project, we're going to use eNet, specifically eNet Multiplayer Peer, as a means to create our server, but also as a way to connect to it from another client. In order to establish a connection, we first need to create a server that listens for incoming requests on a specific port. In this case, I'm going to default our server port to run on 8080, as you can see here by this constant. And to enable that server, we have to set it to the Multiplayer API's Multiplayer Peer, which we've done right here. You can also access the Multiplayer Peer reference through just typing out multiplayer, but I prefer the get tree get multiplayer peer route as it's worked out better for me in my testing. So what we did here is create a new eNet multiplayer peer and ran the function createServer with a default port of 8080. And to enable that server, we have to set it to the Multiplayer API's Multiplayer Peer. So now that we have the ability to create a server, let's create a client so that we can connect to that server. We set up the client using the same eNet multiplayer peer, but instead of create server, we use create client, and we pass in the IP and port where the client should be connected to. However, I want to be a little bit more dynamic with this function, so let's pass in the IP and port as a function parameter. And we'll default the host IP to localhost so you can test easily on your computer. Localhost is just an alias for our computer. Since we're running both client and server on the same machine, we tell the client to look for the server running on localhost. And we'll default the host port to the server port, which we know our server will be running on. We'll access the multiplayer APIs and set the peer the same way we did for the server. Now, if we run the create server function, we'll be able to receive data from other game clients that have access to this server. That could be any other computer on my local network, but for now, I'll just run the clients on the same machine. So this is the most fundamental multiplayer setup that you would need. We have the ability to create a server and the ability to create a client that connects back to that server. Let's create a test function to see it in action. Go back over to the main menu script. Make sure the main menu scene is open. And let's add another button called send test message. I'm going to duplicate the existing button and label it send test message. Open the main menu script and let's wire up these buttons. So to test out sending a message, I want to be able to send a message between the server and client and vice versa. But first we need to wire up calls to create server and create client respectively from the main menu. So under on host game pressed, make a call to create server. And then under the on join game pressed, make a call to create client in the network manager. We don't have to specify any parameters under create client because the default localhost and port will work just fine. And then from the on send test message pressed function, let's call to another one that actually sends a message. And we'll add a parameter that accepts a passed in message. So what we're going to do is print out the message that we received, the peer ID that the message received on, and then the peer ID that the message was sent from. So this call to get unique ID is going to print out the network ID of the peer that received the message. Get remote sender is the peer that sent the message. So that gives us a quick look at the tools that the multiplayer APIs provide. Back under the message press function, let's make a call to send test message. And just put in any message that you'd like. Now to enable this test message function to be called across connected peers, we need to add some annotation to it. We're going to turn it into something called an RPC, which is a remote procedure call. So add the annotation at RPC, and then we're going to add the any peer parameter, and then the call remote parameter. If you hover over the RPC annotation, you'll see some documentation that describes what the different parameters mean. The first parameter is the mode, which indicates who can make calls to this RPC. And we're going to set it to any peer because we want any peer connected to this server to be able to call to it. The second one is the sync parameter, and we're going to set it to call remote. And what that's going to do is it's going to make sure it doesn't run locally. So if I make a call to that function from my computer or my game client, it's not going to also run locally. It's going to only run on the remote connected peers. Now let's test it out to see it in action. But first we need to enable a second game client window. So under the debug menu, select Customize Run Instances, hit the checkbox for Enable Multiple Instances, and hit this up arrow to give us another game client. Hit OK, hit play to run the main scene. First, let's create a server by clicking Host Game, and that will call to the network manager, and we can tell that that worked because it printed out server created. On the second client, let's hit Join Game to connect to that server. And you can see we printed out client peer created, so we know we're connected to the server. So on the host client, let's hit send test message. And you'll notice it says received on peer 1, which was where we got the message, from peer 0. Now you might be thinking, well, that sounds like a problem to me. What is peer 0? Well, that actually is a problem because what we did is we didn't enable the RPC call. So go back to the code. And in order to make an RPC call, you have to add .rpc. And with that .rpc, it enables the networking capabilities of this function. So run it again, hit host game, hit join game. Now hit send test message on the host. And look at that. And you can see we got our message hello there and received on peer with this network ID from peer 1. So just a quick note here, peer 1 is going to be the network ID always assigned to the server or host peer. All other connected peers will have some network ID that looks like this. So basically what this is saying is we received a message hello there on peer with this network ID from the host server peer. So this game client is represented by this network ID, and it received a message from this game client, which is our host or server client. So what does sending a hello message accomplish? Well, this demonstrates that we were successful in establishing a connection between two peers where we were able to send data between them. This is what's at the core of all multiplayer games. Since we've confirmed the ability to create a connection and communicate data between the peers, now we can build on top of that in a meaningful way to bring our game to life. The way in which we send or receive this data generally conforms to some communication protocol, basically a set of rules that computers abide by to talk to each other. In this case, we're using ENET, which is built on top of UDP, a communication protocol suited for time-sensitive applications like video games. With a connection now established, we can use RPCs or remote procedure calls to send data between connected peers. Generally, RPCs are useful for sending data like user input or signal events in the game. The various parameters for mode, sync, and transfer mode are used to modify who can use the RPC and how it behaves. I've touched on the basics in this project, but I'll save a deep dive for a later video. I'll put some links down below, and I'd recommend checking them out if you're interested in learning more. So now that we've created a basic server and been able to connect to it with a client, I want to take care of some housekeeping before we move on. Head over to the Network Manager script. So I want to be able to clean up the network connection in the event that a server or host goes down while it has a client connected to it. And to do that, we need to be able to detect when the server is disconnected or the server goes down. So let's create a new function called setup client connection signals. Let's get access to the multiplayer APIs and look for the server disconnected signal. And let's wire up a function. We'll call it server disconnected. Go ahead and create that function, and we'll add a little debug statement there to know when it happens. Now, because the signal is only emitted on clients, as you can see here from the docs, we only need to set it up from our create client call. So when you create a client, it'll automatically wire up the server disconnected signal so we can turn that into some actionable cleanup. And the best way to clean up our multiplayer peer is to just set it to null. And that will clean up our client connection in the event the server goes down. So let's test it out. So we host a game, and then hit join game. And then let's just close the host window. You can see there it printed out server disconnected. So our client got the notification that the server went down. Let's run one more test, but in this one, let's create 3 debug client windows. So we'll use this window for our host, and then we'll join with both clients. Now let's see what happens when we close the host. Great, you can see both clients receive the server disconnected signal and reset the multiplayer peer. Now to take that one step further, we can actually now create a host out of this client. So I'll hit host game, and then hit join game again. And you can see it created a server and the client peer was created. But wait, there's an error in the debugger window, so let's open that up. So it says the server disconnected signal is already connected to the network manager server disconnected. So what that is saying is because we didn't restart our session when we created a host and then joined again, it ran through the create client when we tried to join the second host. So that means it tried to connect the same function again to the server disconnected signal, but we don't need to do that. So let's prevent that from happening. So all I'm doing here is I'm getting access to the multiplayer API, and I'm asking the server disconnected signal, do you already have a connection to the server disconnect function? And if it doesn't, it'll go ahead and create it. But if it does, it'll just ignore that. So let's run the test again. So we create a host, join game. Great, so we have 2 clients connected to a host. Let's kill the host. Great, both clients disconnected. Now let's start a new host. And let's try to connect this client to it. And you can see there, it successfully created the connection to that host peer and did not error out with that message. And let's take that one step further and send a test message from our host. You can see there a message, hello there, was received on peer with this network ID from the new host, which is this guy, the network ID of 1. And let's send a message back from our client. You can see there we got a message on our host peer from the peer with this network ID, which is this one. Great, so I think that's working just fine. And as a quick side note, if you notice I put an underscore in front of the setup client connection signals function, well, that's to indicate that it's a private function and shouldn't be called outside of this script. You can't actually enforce that, so you can technically call anywhere, but according to the Godot style documentation, it's a good way to indicate a function is private. Okay, so if you are following along, take a pause. If you don't have these changes on a new branch, create a new branch and commit what you've got working so far. So for this demo, I think this is a good place to put some functionality to load the game scene. And we're going to pass in the preloaded game scene, but first we actually need to create a reference to it at the top. So back in our main menu script, I want to load the game scene when a user creates a server or creates a client. So that way we create the server and immediately push them into the game scene. And for the client, I'm going to load the game scene first and then create the client. And I'll touch on more about why I did that in a few minutes. So let's do a quick demo, but first let's lower the debug instances back down to 2. So if we click host game, it kicks us right into the game scene. And then same thing with join client. So great, we have both peers connected and into the game scene. And on the topic of loading in the game scene, let's get our main menu button working. So first let's create a game script. Put it under the scripts folder. Now we can wire up the button press signals. I'm going to remove these for now. So if we're in the actual game scene, we're assuming we have an active network connection. So if we go back to the main menu, we need to make sure that connection is severed or cleaned up. So let's create a function to do that for us. Back in the network manager, let's create a function called terminate connection and load main menu. When developing out some functionality, I always like to put print statements in to help with debugging. So the first thing we want to do is load our main menu, clean up the network connection, and clean up the disconnection signals we've got wired up to our client. So let's create a load main menu function and load the main menu scene. We've got to create a reference to the main menu scene at the top. Oh, extra parenthesis. So let's add a call to load main menu. Next, we want to clean up our network. Let's create another function called terminate connection. And for this, we're actually going to use the code that we've wired up to our server disconnection function. So grab that line and copy paste it down in terminate connection. And since we just did that, we kind of have some redundancy here. When a server disconnects and you're playing the game as a client, I think we should just kick them back out to the main menu scene. So let's go ahead and make a call to terminate connection and load main menu because I think it's handling the same functionality. Okay, let's add a call back up in our terminate connection and load main menu. And the last thing we need to do is clean up our client disconnect signal. Create a function called disconnect client connection signals. And it's basically the opposite of the setup client connection signals. I'm actually going to grab this conditional and the subsequent connection and copy paste it down below. But we need to change a couple things. So I'm going to remove the not. So if our server disconnected, let's change it to has connections. We'll go ahead and say server disconnected signal disconnect. And we'll disconnect the function we use on server disconnect. And then don't forget to add the call under the terminate connection and load main menu. Back in the game script, let's make a call back to that function we just created. And let's run the game to test it out. Create a host. Now we're in the game scene. If I hit main menu, returns me back to the game scene. And if we check the logs, it says it's terminating connection and loading the main menu. And then we can see the print statement there, terminate connection. And we know we're back in the main menu because we can see it. So let's start a host again and connect our client peer. Now we're both in the game scene. And if I leave the main menu on our client, kicks us back out to the main menu, and you can see the connections terminated. Let's see if we can join again. Yep, we've been able to join again, no problem. Now let's kill the host and see what happens. So look at that. You'll notice both clients were kicked back out to the main menu, which is exactly what we expected. And And you can see that reflected in the logs with the 2 print statements to terminate connection and load main menu. And as an extra test, try to start the other window as a host and see if you can join game. And then close the new host. And great, now we have a full end-to-end test and we got everything working as expected. I think it's really good to get this networking lifecycle stuff at a good place before you start developing your game, because then you know you've built everything on a solid foundation. And head back over to the network manager. And let's add one more thing at the top here. I just want to create a variable that indicates whether or not we are a host. And let's default it to false. And then when a server is created, let's set it to true. And when creating a client, let's set it to false, because at that point we are not a host. We'll see why we need this in just a moment. And I believe this is the last change we'll need to make to Network Manager for the entirety of this video. So great job, you have a solid network foundation set up for this game. Make sure to commit what you've got working so far. Okay, let's dig into the game scene. When the player hits host game, we start the server and move them into the game scene, but there's no player there yet, so we need to set up our player spawn functionality. Down in the scripts folder, let's create another one called Multiplayer. This is the way I just organized it. You're welcome to organize it any way that makes sense to you. Create a new script in that folder called Spawn Manager. Go ahead and open it up. Do a bit of cleanup there and give it a class name of Spawn Manager. Create another folder called Multiplayer under the Scenes folder. Create a new scene, and we'll call it Spawn Manager. And you can actually select the node that points to the script we just created. Hit OK. Great. And you can actually close that scene. We won't need to operate on it. So go back into the game scene and add back the ready function. And here I want to load in the Spawn Manager manually to the game, but I only want to do it if we're the host. So that's what we're going to do with the isHostingGame property. Make sure you load the scene and not the script, as indicated by .tscn. Let's instantiate that scene, and then we're going to add the Spawn Manager scene to the game scene. So you may be wondering, why do we only add the Spawn Manager on the host peer? But let's hold off on that. We'll come back to it in a minute. Let's demo the game again and make sure that it gets added to the scene. And to do that, after you've ran the game session, go under the Remote tab. And you can see it says Main Menu, but we're not actually on the main menu, so that must mean we're under the wrong game session. So click around until you see the one that says Game. And you can see there the Spawn Manager has loaded. Now let's make sure it doesn't load on the non-host client peer. Select the other session. You can see it's in game now, and there's no Spawn Manager present. Great, so that's working as expected. So if you remember back when I touched on connection signals at the beginning of this video, I want to use them to spawn our players into the game. So when a player connects to the server, I want to leverage the Multiplayer API's peer connected signal to know when to add them. And we're going to take care of that in the Spawn Manager script. So let's connect a function to our peer connected signal. We're going to select the peer connected signal from our Multiplayer APIs, and let's connect that signal to a new function called peer connected. And the peer connected signal will pass in the network ID of the peer that just connected. And we can print that out in a debug statement. And since we have a peer connected signal, we also want a peer disconnected signal as well. So I'm going to copy paste that line and add disconnected and a subsequent disconnect function as well. So let's test it out real quick. Hit host game and then hit join game. You can see peer connected with the ID 5280. You get the idea. Great, since we know another player has connected to our server, we can spawn their player into the game. But you might be thinking, well, there wasn't a peer connected signal when the server joined the game. Well, that's correct, because it doesn't actually fire because they are already there. So there is no peer connected signal for the servers. So we're going to have to manually add the host's player to the game. So let's add a function called add player to game. And we're going to take in the network ID of the peer. Now, before we can add the player to the game, we need a reference to the player scene. So let's create a reference variable at the top called player scene. And this is going to be a packed scene. This is a way to give us access to a scene to load from file. But how is that player scene going to be set? Well, if we go back to the game script, let's set it during the creation of the Spawn Manager. And we don't have a reference to player scene in the game script yet, so let's create one. We're going to export that variable and it's going to be a packed scene as well. And select the top level game node, and you can see there's a player scene exported here. Go ahead and select it and hit quick load, and then click on the player scene. And you can kind of see the ship there in the scene, so you know you've got the right one selected. So now that we have the player scene set in the spawn manager, we can start adding the player to the game. The first thing we want to do is instantiate the player scene. I like to set the player's name to the network ID. This is actually a common practice. You don't have to do it, but it makes managing the player and performing checks against which peer or player you're working with much easier. I want to also make sure that we have the player authority set to the host or server peer, and I'll touch on the authority stuff in a minute. So now that we have the player ready, we need to add them to the game scene. So in order to do that, we have to have a node where the player actually gets added to. So let's create a new node 2D and call it spawn path, and mark the node as a unique name. That way, once the spawn manager loads into the game, we can easily access it. We access unique nodes by putting a % in front of the name, and I misspelt it, so make sure that the name is also correct. So let's add the player to the spawn path. And as a quick side note, this is a 2D game, but if you are working in a 3D game, the setup would be identical to this, except you'd be working with node 3Ds over here and also in the game tree. Since the spawn manager loads as part of the game scene, we can add the host player as part of the ready function. So make a call to add player to game, and the network ID of the server or host player will be 1. So let's give it a quick demo. Click host game, and there's our ship, and it just fell through the earth. Okay, so in order to use the ship, let's go over to the player script really quick. We can clean up the default character movements by removing the jump and gravity, because we're going to be in space. We don't need those things. And UI left and right means the arrow keys. So let's do another demo really quick. You can kind of see the ship just spawns at the default 00 or wherever that is. And you can move left or right and see the ship move on your screen. Okay, so we've made some progress there, but we can't do much else. So if we hit main menu, it goes back to the main menu scene. And I think while we're here, this is probably a good idea to actually add the more advanced controls. So let's go under project settings, input map, and let's add key bindings for the WASD keys. I'm going to call them up, down, left, and right. So for up, W, down, S, left is A, and right is, of course, D, WASD. Okay, so close that. And then we're going to change these to left, right, up, then down. And since we are working in 2 dimensions now, we need to add another line here for the Y direction. Direction also has another dimension, so let's do .x and then .y. And then also copy this line below and change X to Y in both places. And now we should be able to move around on the screen. And I also know we're going to be going a bit slow, so let's speed it up to 600. Post game. And now WASD should be able to move your ship around in all the places that you can imagine. So if we join game on the other client, you'll notice that nothing happens. So let's get the other player loaded into the game. Head back over to the spawn manager. And since we wired up this peer connected signal to call the peer connected function when another client connects to the server, I think that's a good time to add that player to the game. So let's make a call to add player and then pass in their network ID. Okay, so we should have our second player into the game, right? Let's give it a test. Nothing's happened. I don't see any of the players. Let's check our remote tab to see what's going on. There's nothing in our spawn path. Well, that's weird. Are we under the wrong session? Well, this spawn path, yeah, so here is the host server because we can see the spawn manager is there. So if we look at the spawn path, you'll see the host indicated by player 1, and then the connected client indicated with their network ID. So there are 2 players in the game. Where are they? Oh, they are really far out of space. Okay, so I think what we need to do is fix our spawn locations for the player. Okay, so in the spawn manager, right before we add the player to the spawn path, let's set a spawn location for the player based on the network ID. And forgive me for just copy pasting this code in, but you can have a look for just a second. What I'm doing is checking if the network ID is equal to the host, and if it is, spawn it on the left side of the screen. And I have some minor randomization of where exactly it's going to spawn over there, and I'm setting it to the global transform of the player we're about to add. So if you're not the host player, then we just spawn them on the right side of the screen based on these random ranges I calculated earlier. You can adjust the player's global transform or position if you prefer to spawn them in a different location. So let's try it out. So host, you can see they're spawned on the left side of the screen. And for the client peer, they are spawned on the right. Great, but wait, they're not on the other client, and they're both moving when I use the input controls on the keyboard. So what's going on there? Well, several things. So close that out. So the spawn manager is what adds them to the actual spawn paths and readies the player for the gameplay, but it doesn't actually spawn the player and synchronize them across the connected peers. So that's where a multiplayer spawner comes in. So go into the game scene and add a new multiplayer spawner. I like to move it to the top of the scene. The multiplayer spawner is a built-in node that Godot provides that can be used to spawn in nodes or scenes into the game. For single-player games, when you want to add the player or an enemy mob or anything you want to show up during gameplay, you instantiate some scene and add it to a node path in the game tree. The multiplayer spawner builds on this functionality, but it is supercharged for multiplayer compatibility as it will automatically synchronize those added scenes across all connected clients. So you'll see right off the bat, we have a couple parameters: spawn path, limit, and auto spawn list. For the spawn path, well, that makes sense to use the spawn path we already created, so drag that over. And spawn limit sets the number of nodes that are allowed to be spawned by this spawner. If you leave it to 0, there's no limit, so we're just going to leave it to 0 for now. Then the auto spawn list, well, we're going to want to add the player to this. Select add element, hit this load icon, and select our player scene. Let's look at what the multiplayer spawner is doing. We set the player to auto spawn. What that's saying is when this player scene gets added to the spawn path, this spawn path right here, the spawner will know to automatically spawn that player and synchronize it between the connected clients. You can do this with other things other than players, but for now we're going to use it just to synchronize the player across the connected clients. Let's do another quick demo. You can see that the players are there on the host, but they shot off into space on the client. I don't know if you saw that, but let's check the remote tab to see if they're actually spawned in the game. So we know we're on the server peer because we can see the spawn manager is spawned in, and we can see both players are in the game. But what about the other session for the client peer? Great, you can see that it actually spawned both players there, but they shot off into space somewhere, as you can see by the position, so we're going to have to fix that. Go ahead and close out this session. What we'll need to do is synchronize their position so that once they spawn into the game, the position of them on the host peer will be replicated to the client peer that's connected. So we need to synchronize the location of our player. So I'll go over to the player scene, and in order to do that, I want to use a multiplayer synchronizer. Like the spawner, the multiplayer synchronizer is another built-in tool that Godot offers to simplify some common multiplayer functionality. In this case, by default, it synchronizes configured properties from the authority to all connected peers. This is helpful if you know you have some properties that you want to synchronize, but aren't necessarily event-based, like syncing a player or enemy mob's position, maybe their health, some debuff, or status on the player or power-up. It has a few settings you can adjust, like sync on spawn and how often the property should be replicated. So add one to the top of the player scene. Make sure the root path is set to player, and you can leave the public visibility selected. With the multiplayer synchronizer selected, you should see a new replication tab show up at the bottom. The easiest way to sync a player's position is with its position property. Hit add property to sync, select the player, hit OK, look for position, select it and hit open. And now you can see that we are synchronizing the player's position property. So that's a property that's underlying or built in to the character body 3D. And you'll notice there's two headings, spawn and replicate. Spawn is for, do we want to synchronize the player's position on spawn? And yeah, we do, because we want them to spawn in a specific location across connected clients. And then when do we want to replicate them? Well, because we're going to be moving around, let's leave replicate set to always. If I use the input controls on the host, it's actually applying that motion to both ships across the connected peers, and that's not what we want. And if you try to use the input controls on the connected peer, you'll see the ships are just shaking around a bunch and you can't really move them. Let's do a quick check over in the remote tab. And I select the host player. You'll notice that the node is assigned multiplayer authority 1. Well, what about the other player? It's also assigned authority to 1. Well, am I in the wrong session? Let's check the other session. So this is actually the host. So what does it say? Multiplayer authority 1, multiplayer authority 1. So if we go back to the other client, which is the player 2 that's connected, both of its authorities are assigned to 1. So why can't you move? Well, it's because the multiplayer authority is set to 1. That's why you can't move your player on your client. Okay, that's great, but what does the server having authority over everything have to do with why I can't move my player? Well, for our current setup, when we gather inputs for our player under the physics process function inside the player script, this chunk of code runs as part of every instance of your player. That means on your game client and on the host client. Specifically, this input.getVector is gathering inputs from the host and your local game client. But since the host client has authority, the inputs that it gathers, including no input at all, overrides any keyboard inputs you would make. In multiplayer games, there will always be this concept of authority. I like to think of it as who can make the changes or who has ownership. Okay, make changes to what? Ownership of what? Well, anything in the game. This applies to the game world, objects, players, and even actions taken in the game. It's about who can manipulate or change properties. For competitive games, we may have a server build somewhere, or in our case, where we have someone acting as the host for the game that will be assigned authority. By default, everything on the server peer, the game instance that runs the create server function, will be given authority. We call it server authoritative. In Godot, that peer will be assigned a network ID of 1. It also means anything spawned in the game, regardless of peer, will have server authority by default. Any client that connects and joins the game will have the entire game world, including the player, assigned to that default authority. This points back to the reason why you cannot move your player. It is completely owned by the authority. If our client tries to spawn something, it still has server authority. You cannot change it unless we assign authority over the object to that client. Having a single peer hold authority of where everything should be in the game ensures consistent gameplay for all players and helps reduce cheating. It's responsible for reconciling behavior in the world from the interactions of many players. I'm already in the weeds on this, but I'll put some more links in the description so you can learn more about this fundamental concept. So sorry for the lengthy detour, but if we head back to the player script, this physics process is ran on your peer, your local game client, but it's also executed on the other peer's instance of the game. In this case, that's the server authoritative peer, or the host. Since the server peer has authority, any movements that you try to apply will be overwritten by the server's version of your player's position. So that's why you're seeing jitters or shaking when you're trying to move the player on the client peer. You're basically fighting where the authority peer says your ship has to be, so it's snapping it back into place every time you try to move it. So how do we fix that problem? Well, we need a way for the other connected players to tell the server where it wants to move. So the first thing I want to do is under the player scene, let's create another node and call it player input, and also add a new script to it. Change the class name to player input and add a process physics function. Add a variable at the top for input direction, and that's going to be type vector2. So we'll set the input direction to the input.getVector that we set up earlier in the player script. So you can basically just copy paste that or into the player input. So we need to add a reference to this player input to the player script, create a new export variable at the top, select the player in the tree, and drag over the player input node, and then update the physics process to retrieve the input direction from the new player input node. So we haven't really changed anything, we just moved the logic over into another node. So why are we going to do that? Well, it's because we need a way for the player to inform the server where it wants to move. Meaning we want to give the player authority over their own inputs. So instead of the server telling us where we are, we're going to tell the server where we want to go by sending it our inputs. So we need to add another function called enter tree. So this is called very early on when a node is added to the tree. So we need to change the authority over the player inputs to that local player client. So we're going to do that by calling set multiplayer authority. And we're going to set the authority to the name which we gave to the player. And if you remember, back when we spawned the player into the game, we set the player's name equal to the network ID. And that's exactly how you set the multiplayer authority. It's always assigned based on the network ID. Let's jump back over to the player input really quick. And if you remember, this is going to be running on every instance of the player. So wherever this player exists or is running around in the game, this will also be running. But we only want to collect the inputs from the local player or local client controlling this player. So we need to wrap this with an authority check. However, in this case, we won't be checking if this is the server or host authority. We'll be checking that this is running only on the client peer, which now has authority over the player input object because we just set it right here with this line. So the player itself will have server authority, but the player input node will be assigned authority, which has this attached script to it, which means if we wrap it with this multiplayer authority check, it's only going to gather this input direction on that local client's peer. I hope that makes sense. However, we still haven't told our server, right? Because we're gathering this on the local client. We still need to tell the server what this input direction is. So in order to do that, we're going to need another multiplayer synchronizer. So under the player input node, add another multiplayer synchronizer, call it input synchronizer, change the root path to player. And for now, we'll leave public visibility on, but I think we're going to change that in a minute. In the replication tab, type out player input, because this path is based on the root. And since the player is the root, the path is going to be player input and then input direction, because that's a property inside the player input script. And we'll go ahead and start synchronizing that on spawn, and we're going to always replicate that. So anybody that has access to this synchronizer will be getting or receiving the input direction property, hence the public visibility checkbox. So what this is doing is now when we use our keyboard inputs, the input direction property is synchronized to all connected peers. So now when the server runs the physics process for the player, the input direction is now sourced from what the client's inputs synchronize to it, which is why we wrap the player input code in an authority check, because we don't want the server peer to overwrite the input direction, especially when you're testing two different peers on the same machine. That said, this physics process is still being executed on all instances of the player, but since this is server authoritative, we really don't need to be setting direction on our local peer. We only really tell the server our inputs and then let the server make those calculations of where the player should be moving to. And then the server synchronizes that position back to our clients. Because of that, it still may cause some shaking when you try to move the players. If you do a quick demo at this point, you can see that I can control the host independently from the client. I don't see too much shaking going on, maybe a little bit. It's not really apparent in the recording, but I'm suspicious that that may cause issues in the future. So let's go back to the code and let's wrap all of this movement with an authority check. So now, where does this code get executed? I'll let you think about it for a second. If you said on the server or host, you'd be correct. This is multiplayer authority check only applies to the player, which is still owned by the host or server peer. Remember, we only change the multiplayer authority over the player's inputs, not the actual player itself. So the server's instance of this player will get the updates from what the player's pushing on the keyboard, right? So their player inputs. It applies, now that we're on the server instance, it will apply those inputs that it got from the client peer to the player's velocity, move the player, and then because we're synchronizing the position, the server now synchronizes the position of that player back to the connected peers, and then you'll see it move on the screen. If you are thinking, well, isn't that going to cause lag? You're doing a whole round trip before you move the player. Yes, it absolutely will cause lag. The second you get off your local computer, maybe even move this to another computer on your local network, you are very likely to see some lag show up. Once you are ready, we'll introduce lag compensation to help with this problem. If you are feeling ambitious, I already have a few videos on that you can check out after this one. If you'd like me to continue with this series, let me know down below and I can show you how to add lag compensation to this example. Run a quick demo of the game, and let's have a look at the remote tab. So right now we know we're on the client because we don't see the spawn manager. So let's go down to the debugger tab and change session. And let's click on the host player, which is the little player character with the name of 1. You notice the multiplayer authority is 1. And they have a player input object. So let's look at that. The player input owned by the host server is 1. That's what we expect. But if we look at the other player's peer, the multiplayer authority is now set to the peer ID of the client that's connected to it. So we know that even though the player has a multiplayer authority of 1, the input is now updated to whatever the network ID is of this peer. That's exactly what we want. So anything under this node, including this synchronizer, will also contain that same authority. So because of that, we can now move around on the connected client and use our keyboard inputs that will synchronize to the host peer, and you'll see that ship move around. Even though this does a round trip, you can't really see any lag because it's on one computer. There is definitely a round trip there. And if we look on our host peer, we try to move the player around, it is also correctly synced because, well, it's the authority and it has the authority to do that. And that said, we take a peek back at our code. I did wrap all that movement code with an isAuthority check. So none of this code is running on the client connected peer. It is only running on the host peer. So that really hammers home the fact that we're moving the player on the host and then synchronizing their position back to this. So you're not actually moving the ship when you press your keyboard. You're just telling the server host, hey, this is where the player wants to go. The server applies the input that it received from you and then moves the player and then synchronizes that motion back to the other peers. You may be wondering, why don't you just give authority over the whole player? Why just the inputs? Well, you can, if that's appropriate for your game type. Okay, but what do I mean by that? Well, some games have a different network topology or network model where it is suitable to have that full client authority setup. We generally refer to that as P2P or distributed authority. There is a time and place for that model. Co-op games is one example, or maybe you just don't care about cheating and you want a free-for-all. Distributed programming comes with additional complexities, so you'll have to keep all that in mind. I'll link to a good article by Moss Bandwidth that you can check out for further details. I also think it's important to at least mention what network topology we are constructing here. Network topologies are like P2P, dedicated server, or relay, to name a few high-level categories. There are many variations of granularity for each of these, but that's way out of scope for this video. This demo, where one player acts as the host and authority, and all other peers basically render the visual components simulated from the server, is considered client server with an authoritative client host. That's a mouthful. Sometimes I refer to this as P2P client host, as technically you are connecting to another player, along with all the other players in the game. I would say this is a fairly common setup and works well when you want to use Steam, plus you can rely on their free network. But again, this decision relies heavily on your game type. I know that's a lot to take in, but the more you do this and the more you practice and struggle with it, the more it will make sense. And let's go one step further. Let's select the input synchronizer for the player inputs and uncheck public visibility. And if we look at the docs, it says synchronization should be visible to all peers by default. So there are ways using set visibility for or add visibility filter to configure fine-grained visibility options. So what I'd like to do is limit the public visibility to only broadcast my player inputs to the server. We don't really need to do this for this game because it's only a two-person game, but if you are working on a more than two-person game, you may not want to broadcast the inputs to all players. So to change that, let's get a reference to the input synchronizer. Oh, and by the way, we need to add a class name to player up here. So now that we've created an export for the input synchronizer, select the player object and connect that input field. Perfect. And let's create a new ready function. And we're going to use the set visibility for function to only send data to peer number 1. And then of course we have to say whether or not that data is going to be visible or not. So let's just say true. So we're setting the visibility of the input synchronizer to only go to this peer. And we're going to set it to true, which means yes, it's going to be, I guess you can just toggle off the visibility if you needed to do that. So let's just do a quick demo of that. But I want to launch 3 windows. So we'll host game and join as a client and then join as another client. You can see that all 3 can move independently. Depending on which window you have selected, will be synchronized as expected. And that's exactly what you want to see. And we did that with only setting the visibility to the host peer. Okay, but why did you show us that? What's the significance? Well, I want to highlight the visibility setting on the synchronizer, as it can be useful to limit which peers or players in the game receive that data. That can be important, say, in the case where maybe a player is stealthed and you don't want to share that data with other players' game clients. Or maybe the player's too far away or has some hidden power-up. Regardless of the numerous scenarios this can pertain to, I just want you to be aware that there are tools like set visibility for and replication mode that can be used on the multiplayer synchronizers to solve some of the problems you may run into. This example demonstrates how to limit sending your input data to only the host, but you can imagine if we didn't limit it to just the host, there's a potential exploit here where you may know what the other player is doing before it's rendered on the screen. And while you commit this latest round of changes, I want to wrap up this section with a quick comment on the multiplayer spawner. If you have an ongoing game and there are mobs or something that have already been spawned in with a multiplayer spawner, by default, they will automatically show up for the other players when they join in. So out of the box, the multiplayer spawner will synchronize whatever objects it's responsible for to those late joining clients. Let's select a different ship for player 2. So if we look at the animated sprite that I've already preloaded, we have 2 animations, default, which is the player 1 ship, and ship 2, which is going to be for any connected peer other than the host. So let's create a constant that maps to those. And another export for the selected ship. And we'll default it to the default ship type. We select our player. You can see that it's been set to default. And we're going to export a variable to the player sprite, which is the animated sprite 2D that we've got there. If we select our player object, drag over the animated sprite 2D, and then down in our ready function, let's kick off the animation to the default selected ship. Since the selected ship defaults to the player 1 animation, we need to add something over in the spawn manager that will set the selected ship to the player 2 ship. In the add player to game function, I'm going to piggyback on this network check conditional here, meaning if it comes to the else statement, we know it's the player 2 instance. So let's set the selected ship for player 2 here. And we're going to set the selected ship to the first index of ship types, which back in the player script maps to ship 2. And if we look at the animated sprite 2D, ship 2 is this animation here. So let's run a quick demo, and you can see it didn't work. Close out that session. So why isn't this working? So even though the selected ship is set on the player, the other connected peers have no idea what it was selected to. So we need to be able to synchronize this selected ship property. So to do that, over in the player scene, select multiplayer synchronizer and paste in selected ship. You do not want to type out player : selected ship. That will cause an error. Just type in selected ship. Because the root of this node is set to player, it should automatically pick it up and give you player : selected ship. Also, we only want to synchronize on spawn because for this demo, we're not going to change the ship in the middle of the game. So that means we can change this replicate property to never. And you can see now we have the ship for the connected peer or player 2 that is different from the host peer. Great, so now we have player 1 and player 2 moving around in the scene with their different respective ship animations. And to test something out really quick while we're here, hit the main menu button on your client and then hit join game again. You'll notice that we have a leftover ship kind of floating in space there. It's kind of neat. It'll actually get attached to the collision shape and kind of stop you from moving. So we need to have a way to clean up that extra ship in case you leave the game and come back in. We don't want to see any extraneous ships floating around there. So back in the spawn manager, when a peer disconnects, let's remove them from the game. We're going to leverage the spawn path of where they were added, find them by network ID. And in this case, we need to set this owned to false as it's defaulting to true. Otherwise, we won't be able to find the player correctly. So if we find a player to remove, let's delete them from the game. And we can do that with a call to queue free. So let's make sure that's working. We can move both players around, go back to the main menu on our client, join game again. And as you can see, there's no longer an extra player there. And to triple check, go under the remote tab. You can see there's no spawn manager, so we know we're on the client peer, this one. You can see there's only 2 players there. Now let's double check the debug tab. Oh, we have some errors we'll come back to in a second. Go to the other session, which in this case is the host session because we see our spawn manager, and there's only 2 connected peers, which is what we expect. Great. So let's have a look at what our errors are. No multiplayer peer is assigned, unable to get unique ID. Okay, so what'll happen sometimes is when your player script is running, there's multiple instances of it, right? It's on your local machine, on other connected peers machines as well. If the network connection is severed and this authority check is still being ran by one of the instances of that, it will actually throw an exception and say, we can't actually check for authority because we don't have a multiplayer peer established right now. So there's a quick workaround to fix that, and that is to add a check for, do we have a multiplayer peer? So I'm just going to add that there, and you may notice this pop up in a couple other places. Let's see if it is actually already doing that. Yeah, right here under this physics process. So let's go ahead and add that check here as well, underneath the player input script. And if we run through the act of quitting and joining back to the game, you can see there's no more errors down below. So now let's shoot some stuff. Head back over to the player script, and let's create a new script called weapon. And we're going to attach that script to a new node in our player scene. It's going to be type node 2D. And just name it weapon. Attach the script you just created. Great. Next, let's create a scene. Set its type to area 2D. And we'll name it projectile. Let's attach a new script to it with the same name. And we'll come back to that in a second. Head back to the weapon script, and let's export some references to a few things. So this weapon is going to need access to the player inputs, the projectile scene we just created, and then a spawn path for that projectile. But first, let's head back over to the player input script. Add a signal for weapon fired. Then in our physics process, we need to check to see if the fire input was pressed. Use the is action just pressed. We'll call that fire, and then we'll emit the signal that we just created. But wait, we don't have a fire action yet, so let's go create one. Project settings, input map, new action called fire. I'm going to map it to spacebar. You can map it to left click on a mouse or whatever button you'd like. Head back to our weapon script and the player scene, and let's wire up the player input and select the projectile scene. We need a projectile spawn path, so let's go ahead and add that. It's going to be another node 2D, name it projectiles. There are a few ways to approach how we can go about spawning and synchronizing projectiles. For this specific demo, I'm going to stick with using Godot's high-level multiplayer spawner and synchronizer. But once you get the hang of the basics, you'll likely need to upgrade to something that's a little bit more latency friendly. And don't forget to drag over the projectiles node over to the projectile spawn path. In the ready function, connect the weapon fire signal to a new function called weapon fired. Let's call to a new function called spawn projectile. So basically what we're going to do is when I hit the space bar that emits this weapon fire signal, our weapon is going to listen for if that signal is emitted through this connection here. And when it is, it calls to this weapon fire function, which will spawn our projectile. First, we need to instantiate the projectile scene. And let's spawn the projectile at the same location as the ship that's firing it. But first we need a reference to the parent player, which we can get once the player scene loads with this call to get parent. Since we want to spawn this projectile, we need to add it somewhere to the game. Unfortunately, we already created that with this projectile spawn path, so grab a reference to that and add the projectile as a child. We've got a good start on the weapon scene, but let's dig in over to the projectile script for a minute. Let's add a animated sprite 2D, select the sprite frames, quick load, and I already have a projectile sprite frames resource added, so just select that. If you take a look at it, it just looks like a little missile. Oh, and while we're in here, make sure the autoplay on load is set for the default animation. Perfect. Oh, and here's the explode animation. We'll get to that in a second. And because this is pointing in one direction, we'll need to be able to change it based on which player shoots it. So we need to grab a reference to that animated sprite. So let's drag that reference over. When the projectile is spawned, we need to figure out which direction to spawn it so that the animation plays correctly. So let's create a variable to track that. I'm going to create something called flip projectile. And if it's true, we'll flip it. But I'm not exactly sure which direction it spawns to begin with, so let's just check and see first. So it's spawning in the wrong direction by default or on the host peer, so let's flip it the other way when it's the host, which means I'm going to set this to true by default. Great, now it's the correct direction. And now we need to change this to false if it's the client peer that joins. So back in our weapon script, let's add a check to see which player it is. So if it's not the host, let's not flip the projectile. This is getting a little confusing. Maybe I should just flip the projectile in the sprite frames by default, but you get the idea. I'll let you sort that out if you need to. So let's run a test. And it looks like we're not going to be able to test that yet because we haven't finished spawning our projectile. So let's go back to the player scene, and we need to add a multiplayer spawner to the weapons so we can get the projectiles to synchronize across the clients. And let's set the spawn path to projectiles. And then our auto spawn list, let's select the projectile scene. This is very similar to what we did with the player. So if we do a quick demo, it's spawning on the host, and it's also moving around with the movement of the ship, which we got to fix. But on the client, it's not spawning at all. So what's going on there? Well, if you think back to that whole authority thing, this weapon fire is called from the local client, so the connected peer. Because if we look back at player input, remember this whole is authority check? This is only admitted on the local client. Well, that's going to cause a problem. Because if it's only emitted on the local client, this weapon signal will only fire and the server has no idea that you want to actually spawn the projectile. So what does this sound like a good use case for? If you said RPC, you'd be correct. So let's turn this spawn projectile function into an RPC so that our players can communicate to the server that they want to fire a weapon. For this setup, we want any connected peer to be able to call to it, which is good because that allows us to tell the server what actions we want to perform. And we're also going to call local so that when the host player wants to spawn a projectile, it also runs as well. However, the call local also means that on the connected client, it will also run locally and on the host authority. And we really don't want it to do that. We don't need to be adding extraneous childs on the local client because we're spawning it with a multiplayer spawner. That's going to cause some problems. So let's wrap this spawn projectile with a is multiplayer authority conditional. And in this case, the authority is the host or server. So even though it will be called locally on the client peer, it's just going to be ignored because the client peer is not the authority to spawn projectiles. So remember, we need to come up to this spawn projectile function and make it an RPC call. And now that I said all that, we're going to make one more change that will make this conditional call to is multiplayer authority kind of irrelevant. So what I mean by that is with this RPC function, we can actually call to specific peers. So if we know we only want to contact the host or authority in this case, let's just put the host authority's network ID here so that this will only be called on the host. It can be called from any other connected peer, but it's only going to execute on the host itself. And because we have call local here, when the host calls it, it'll also be called on its own peer so that it will correctly spawn the projectile. So technically, We don't really need this is authority check here, but I'm going to leave it just for illustrative purposes. You can see it spawned the projectile on both machines. It's actually spawning on top of them because we're not actually synchronizing the property of position yet, but we'll get to that in a minute. But if we go on the client side, we hit spacebar, it spawns on the client, but it's nowhere to be found on the host machine, and it's also facing the wrong direction. If we actually check the remote tab for the host server under the client peer projectiles node, you'll notice that there actually is a spawn projectile even though we don't see it. And if you look at the position, it looks like it's spawning off screen. So I think I know how to fix that. So if we go back to the projectile scene, let's synchronize the projectile by adding a multiplayer synchronizer. Make sure the root path is set to projectile. And down in the replication tab, we want to synchronize the position. And we should synchronize that position on spawn and always replicate its position because it's going to be moving through space. Well, we haven't added that yet, but we will in a second. And it looks like we're getting some errors when trying to auto spawn that projectile. Something about unable to spawn with a reserved name. Make sure to add child with the second parameter set to true. So right here under add child, we can do comma true. Let's try it again. Great. You can see that it spawned the projectile correctly on both machines. Perfect. Now let's try the client peer. So you notice it's still not spawning correctly on the client peer. Well, it technically is. It's just somewhere else. So why is that happening? Why is this so wonky? You'll notice that it's moving as part of the ship, and I don't think that's how a missile is supposed to move. So let's try to fix that. Over in our player scene, select the projectiles node, and under visibility, I want you to select top level. So what that means is when the projectile spawns, it's not going to inherit the transforms from the player when you move around on screen. It's going to be floating there as if it's its own thing. And it only looks like it cares about the transform of the player ship because we set the global transform of the projectile equal to the transform of the player parent. So now with that set, let's test it again. See, it's spawning but doesn't care about where you're moving. And let's try it on the connected peer. Same thing. Perfect. So let's fix the orientation of the missile for the player 2 ship. So we're already setting the flip projectile, but why isn't it applied to the client peer? Well, if you said because it's not replicated, you would be correct. It has no way to know that we've actually flipped the projectile because we did that action on the authority and that isn't translated over the network to the connected peers. So I need to do that. So in the projectile scene, select the projectile synchronizer, and actually we need to go into the projectile script and let's copy the flip projectile property and add it to the replication tab. And since we only care about this on spawn, we can set when to replicate to never. So let's double check that it's working, and you can see now it's spawning in the correct orientation. So let's get this missile to shoot across the screen. Instead of a process, we're going to use physics process. We need to create a speed variable. Let's default it to 600. And then let's just move the projectile across the screen with this translate function. We're only going to apply the translation to the X axis, so we're not going to have anything in the Y. So it's just going to move from left to right horizontally. All right, look at that. You can shoot missiles now. Now let's test it out on the client peer. Oh, wait. They are going the wrong direction. Okay, so let's go back to our projectile code. We have this flip projectile property that is a Boolean. I think we should change this to the integer so that we can flip the direction down here as needed. Let's change this variable to flip direction. Make it an int and default it to 1. Then change the conditional to use flip direction and only flip it if it's greater than 0, which means if we're on the host, flip the ship's sprite the other way. If you're thinking this seems a little wonky, you'd be correct. I recorded this thinking the orientation was the other way around, but since this is a trivial matter and is used for the rest of the video, I just rolled with it. Next, go to the weapon script, and where we instantiate the projectile, change flip projectile to flip direction. And if it's not the host, set the flip direction to -1. Then back to the projectile, let's multiply our dist variable by the flip direction, which literally flips the direction of travel. We also need to update our projectile synchronizer. Remove flip projectile and add in flip direction. And we only need that synced on spawn, so set replicate to never. as we'll keep our players on the same side throughout the game session. Let's run a test. Player 1 looks good, and let's test player 2, and good. Our projectiles are moving in the correct direction. But let's take a quick look at the remote tab. And you'll see that we have all these projectiles that have been fired for each player. We need to clean those up once they leave the screen. So at the top, let's add a onReady variable for the visible on-screen notifier. Make sure you select the notifier 2D. And over in the projectile scene, you need to add a visible on-screen notifier node. Make sure you get the notifier and not the enabler. Drag over a reference to that. And I'm going to mark this as a private variable. And down in the ready function, let's wire up the screen exited signal to queue free when it leaves the screen. But we actually only need this to happen on the authority or the host. So let's wrap this in an authority check. So when queue free is called on the host, it'll automatically despawn on the client as well. Okay, so let's check to make sure that our projectiles are cleaned up when they leave the screen. So I have the projectiles node selected under the remote tab for the host player. You can see there's several of them in there. You could, oh, and look at that, they're all gone. Perfect. Now let's check to make sure it happens for the client peer. And you can see they're getting cleaned up successfully. Excellent. So the next thing I want to do is let's detect if the projectile collides with something, like another ship. So let's add a collision shape 2D. Create a new capsule shape. Need to turn it on its side. And that looks about right to me. Select the projectile base object and then the node tab, and then double click on the body entered signal. And in here, we want to detect whether or not we've collided with another ship, but we don't want to collide with ourselves. I know that's going to be a problem. So we need to add a fired by property. And jumping back over to the weapon script, let's go ahead and set that. And we'll set the name to the parent. Back in the projectile script, we'll just add this conditional here that says, if we've collided by ourselves, just go ahead and return. And we do that by checking if what we collided with is equal to the same thing that fired the projectile, then just go ahead and return that or ignore that collision. Otherwise, if the body is another player, let's go ahead and show the explode animation. Test it out. You'll notice there's some issues. It's automatically exploding as soon as it comes out of the ship on the client peer, and it also keeps going after it makes a collision. So we need to make a couple adjustments. First thing we need to do is set the speed to 0 when it collides with something. We don't want it to keep going. The second thing is we need to stop looping the explode animation once it kicks off. Select the animated sprite and the explode animation and turn off this little looping animation option. Let's try it again. So it's still exploding as soon as it comes out of the host ship on the client peer, and then it's still stuck on the screen. So we need to do something to fix that. Well, the first thing we can do is just actually remove the projectile once it makes a collision. So that's easy enough. We can do that by calling queueFree on the projectile sprite when the explosion animation finishes. The other problem is this fired by name isn't actually getting detected or set on the client connected peer. So we need to also synchronize that. That's why you see the explosion happening as soon as it comes out of the ship on the connected client. So paste in fired by name, and we only need to replicate that on spawn. Perfect, everything looks great. Projectile gets shot by either client and will explode. And as soon as the explosion animation is finished, it's removed from the screen. This is exactly what we want. So I noticed there's an error down on the debugger tab, so let's take a look at that. On despawn received, returning unauthorized. So that sounds like an authority issue. Do you have any idea what that could be? Let's take a look at the projectile script. So I'm going to go out on a limb and just guess that this queueFree is running on both the server or the host and the connected client, because onBody entered exists for both contexts. So I think we can wrap this queue-free call here with a authority check. So it looks like we solved one error, but got another one. It says that the signal animation finished is already connected to the given callable Area 2D projectile queue-free. So what I think is happening is the on-body entered signal is being fired multiple times on the authority in this case. So it's actually trying to connect this animation finished multiple times. So let's just make sure we don't already have a connection if this happens to get called multiple times. So we can do that by checking if the animation finished signal does not have any connections. Let's try running it again. So I'm testing this as hard as I can to try to break it, but it looks like we've got it fixed. I'm going to call this one resolved and move on. And the next thing I want to do before we move on is let's wrap the physics process in an authority check. Just like we did with the player, where the process physics should only be executed on the host, the same thing applies to the projectile. And I'm not sure if you noticed it, but it seems like the projectile is less jittery when it's moving across the screen. So I think we've got this part wrapped up. At this point, I would recommend committing your working changes. We can move around and fire missiles, but let's have our ships take damage when hit. That means our projectiles have to give damage and our players have to have some health. I'd like to implement this part with some composition principles where we use components to piece together the functionality. Components can help with the encapsulation of functionality for improved maintainability when building out your game. I leveraged some component tutorials by Heartbeast, and I found them very helpful when putting this together. I'll put some links below if you're interested in learning more. It's pretty common to use an Area 2D to detect when something has impacted an object during gameplay, but instead of writing this logic over and over for each projectile, player, or enemy in your game, we can create a single reusable component that just attaches to those objects to easily enable that common functionality. And for this part of the video, that's exactly what we're going to do. So create a new folder under scripts called components. I want to create something that captures the logic of causing damage, in other words, hitting something. So let's create a new script and call it hitbox component. Open it and give it a class name, hitbox component. Let's change the type to Area 2D. This provides us a way to register a hit when things come into this node's area. Since this will be causing damage, let's export a new damage variable. Now on the other side of things, let's make another component called Heartbox. Create a new script, name it Heartbox component, update its class name, and the way we'll set this up is that hitboxes will only register a hit if it comes into contact with a hurtbox. That means our hitbox component can be attached on objects and ignore other things that we don't want it to register a hit with, but then when it comes in contact with another object, say like a player that has a hurtbox component attached to it, then the hit will be registered and we can apply the damage. So let's reflect that setup in our hitbox component. We're going to connect the area entered signal provided by Area 2D into a new function called onHurtboxEntered. And like I said before, since we only want to register hits with hurtboxes, that's what we can expect to enter the area of this hitbox. You may be thinking, why didn't we pass in the hurtbox component here? Well, remember, we're still connecting a signal that's provided by Area 2D, and that signal does expect an Area 2D to be passed in, which works out for us because the hurtbox component will also be in Area 2D. So let's go ahead and update that now. So let's assume our hit component runs into something. What's the first couple things that we want to do? Well, we want to make sure that we don't hit ourselves. So let's first add that check to ignore any contact that may be with our own player in the game. So we're checking that the fired by name provided by the projectile script that this hitbox will be attached to does not match the hurtbox component's parent name, which is going to be the player's name of the hurtbox that it's attached to. So this is a quick way to make sure the player doesn't get hit by its own projectiles. The next thing I want to make sure is that the components that this does come in contact with are actually hurtbox components. You may want to adjust this if your game is going to be colliding with other things, but for this demo, I think it'll work out fine. So now that we are ignoring any collisions that we don't care about, we need a reusable manner in which our projectile can act when it comes into contact with something. So we're going to use a signal to accomplish that. So this hitbox will be attached to our projectile, and when it comes into contact with a hurtbox, we want to emit this hit hurtbox signal. And then we'll pass in the hurtbox that we just collided with. Again, hurtbox component will be attached to the player. Before we go any further, let's take a look at how this is going to work. Go over to the projectile script. Currently, our projectile script uses this on-body entered signal to register when it impacts with something. So we're going to replace the use of this signal with the hitbox component. So the first thing we need to do is register a hitbox component with this projectile. So over in the projectile scene, add a child node, search for a hitbox component. Perfect. We do have a warning here for not having a collision shape, but I'll come back to that in a minute. So now that we have a hitbox component, let's create a variable to reference that. And since the projectile needs to know when it hits something, let's connect to that hit hurtbox signal that we just created. And we can just replace the use of this on-body entered function with that. Make sure you update the parameters to a hurtbox component. And since we're already making sure the player doesn't hit itself with its own projectile, we can actually remove this check. We also don't need to check for if we're colliding with a player anymore, because back in our hit component, we actually make sure that it collides with a hurtbox. So we're not going to rely on hard coding player references inside this anymore. So let's clean up this function. Okay, looks good. And go over to the projectile scene in the scene tree, and let's disconnect that on-body entered registration. And I think I'm going to mark this hitbox component as private. Okay, let's go back to the hitbox component. So the last thing we want to do is tell the hurtbox, so the thing that's attached to the player, that we actually hit it. So in other words, when the projectile collides with the other player's ship, we tell that ship, hey, you've been hit by some projectile. And the way we're going to do that here is to create a new hurt signal over in the hurt component. We'll do that in a second, and we'll emit that signal with a reference to the projectile itself. So let's go over to the hurtbox component and finish that hurt signal. And as you can see, our hurt signal over in the hurtbox component receives a hitbox. Okay, so from here, let's open up the player scene. Now we could take the hurt logic and stick it in the player script, but I don't want to muddy up this logic here. So I want to create another component that will handle taking damage. So let's create one more called hurt component. Open it up and change its name to hurt component. And this is going to have a reference to our hurtbox component. But first, we actually need to add the hurtbox component to our player. So go over to the player scene, search for hurtbox, not hurt component, but the hurtbox component. And again, we'll come back to the collision shape in a minute. And now let's add a hurt component to the player scene. And that's this one. So right now, the hurt component will take a hurtbox component reference. So let's wire that up. So since the hurtbox component only tells us that we've been hit by a hitbox, we need to be able to process that hit and take damage. So we need something to track the player's health. Let's do that in something called an attribute component. So again, let's create another component. Create a class name attribute component. And let's create a property that will track our player's health. I think it's important to know when our health changes. So in case it does, let's create another signal called health changed. And looking ahead, I think it might be a good idea to have a signal that tells us when the player is dead or runs out of health. So let's use this health change signal when our health changes. This will be helpful to leverage if, let's say, you wanted to update some UI element like a health bar when the health value changes. And let's emit the no health signal when their health reaches 0. I think it's also going to be helpful to have a function to reset their health, like if you want to restart the match and put all the players back to full health. So let's add that helper function here. So I set the health to a starting health variable that we can add to track what the starting health should be for the player. And for now, we'll set it to 5. So let's head back to the hurt component. Now we need to apply the hit damage to our health attribute, which means we need a reference to the attribute component, which also means we need to add an attribute component to our player to track their health. So let's drag over the attribute component to the hurt component. So if we look back where we left off at our hurt box, we created a signal called hurt that should register hits when it comes into contact with the hitbox component. So let's connect to that signal so we know when a player is hit. So let's use this inline function to subtract the damage from the hitbox from the attribute component's health. And I like printing a debug statement that tells me what the player's current health is during development. So our player has an attribute component which tracks its health. And by the way, you can track other things in here. We're just going to start with health. And then we use a hurt component. It has a reference to the attribute component in hurtbox. And all the hurtbox component does is it enables the object that it's attached to take damage. And that's what we're doing right here. So when our player's hurtbox is hit by a hitbox, so we subtract the health from the damage that the hitbox component deals. Through the use of these components, we're able to add health and maybe some other stuff to our player object. We're enabling them to be able to be hit by something. And then we created a component to handle that. And this is nice because it keeps our player script clean from all the clutter, because you can imagine all this would add up over time. But by putting it in these nice little component chunks, we're able to remove and add them as needed, or apply them to other objects if you wanted to extend the same functionality to some other object in your game. Okay, so let's take a look at this warning. So it's saying we don't have a collision shape. So let's take our existing collision shape and add it underneath the hurtbox component. And now our player is complaining about an error because it doesn't have a collision shape because the player is of type character body 2D. So I actually think I want to fix that really quick. So let's head over to the player script. And of course, right now the player is a character body 2D, but I think we can change that for this demo. So let's head over to the player scene and change the type to a node 2D, and then update the script as well. That's also going to cause some problems in our movement. So because we moved away from a character body 2D, we no longer have a velocity property. So let's create one. And let's update the references. And we also can no longer use move and slide. So let's use translate instead. And because we're not using the move and slide functionality anymore, we actually need to apply a delta to the velocity. Let's test it out really quick. And it looks like the movement is still working as expected. I know we created our player originally as a character body 2D, but since we've moved away from that and are now using hurt and hitbox components to register our damage, I think it might be a bit overkill to leave it at that type. And of course, there are use cases where you'd want to stick with using a character body 2D. There's some functionality that it provides that you may want to leverage. And in that instance, you would just rework your player design. And now we need to fix the projectile scene. So drag the collision shape under the hitbox component. And then let's change our projectile type back to a node 2D. And make sure you update the projectile script as well. And there's one more change we need to make that I just remembered over in the weapon script. Change the instantiation as an area 2D back to a node 2D. Let's kick off a demo and see how everything's working out. So it looks like we wired up everything correctly. Our player health is being reduced by 1 point, as you can see printed out in the logs. But it looks like it printed twice, so I think we might need to wrap something in an authority check there. So let's go back to the code. Let's check back in with the hurt component script. So if we look at the output logs, you can see that it was printing twice each time the player took damage. And the reason why is because each time this hurt signal was emitted when the player took damage, it's running this function on both the local client instance of the peer and the remote instance, which is the authority host. So because we have a server authoritative setup here, we don't need to be subtracting health on the local player. And I think we should actually synchronize the health instead of updating it locally on the client. So let's wrap this with an isAuthority check. And then go back over to the player scene, select the multiplayer synchronizer, and let's add a reference to the player's health from the attribute component so we can synchronize that with other clients. And we'll synchronize it when the player spawns, and then we'll replicate it when it changes. Let's make sure everything is working. Great, it looks like it's printing out the health correctly now, and it's still updating as expected. And make sure you check whatever functionality you're testing on both the host authority peer and also the client peers as well, because sometimes things will work on the host and not the client, and vice versa. I've seen that come up a lot over the last couple years. And now that our players can take damage from projectiles, let's add a health bar to wrap up this section. So go over to the player scene, create a new control element, rename it health bar container. Let's switch over to the 2D view and create a progress bar called health bar. In this case, we'll use a texture progress bar. Rename it health bar. Now I've gone ahead and found a nice layout for this, so I'm just going to show you the settings that I used. And these are the layout settings that I use for the health bar. But let's create a health bar that can change color. So under textures, where it says progress, select gradient 2D texture. Select the texture and change the width to 100 and the height to 8. You can adjust this to make it look best for your game. So select the gradient. So I'm going to select this box to change the color. Double click. So I'm going to change it to this green color. This will be the starting color of the health bar when you're at full health. And technically I don't want to use a gradient color at this point, so I'm going to delete this other node. Now before you move away, this is a really important point here. Under resource, select local to scene. And you need to do that for both the gradient and the progress texture. And the reason why we do this is so that the health bar will update individually per player in the game. Otherwise, all the health bars update together. And then scroll down to the range, set the max range to 5 because that's going to match the health value that we have for each player, and then set the current value to 5. And at this point, if you did everything correctly, you should see a green health bar show up. So it'll look something like this. So I think this is good enough for our demo game. Let's head back to the player script, and I want to be able to change the health bar based on how much health they have left. Let's add another variable called health colors. And let's grab a reference to the attribute component. And the reason why I wanted a reference to the attribute component is that you remember when we created that signal for health change? Well, I'm going to leverage that to update the player's health bar. So let's wire up the attribute component's health change signal to a new function called health changed. Now let's set the health bar value equal to the player's health. Oh, but first we need a reference to the health bar. Now select the player scene and connect up our health bar and attribute component while we're over there. And let's set the health bar value equal to the player's health. And let's test it out and see if our health bar changes as we get hit by projectiles. And it looks like it's working as expected on the client peer and also on the host peer. But let's have it change color as the health gets lower. So the health bar's texture progress attribute has a gradient and colors property. We're going to set that to the health colors that correspond to the current health value. And that health colors comes from the array that we created earlier on. So let's make sure it works. So as you can see, the health bar is changing color as it gets lower and lower. It goes from green to yellow to red, orange, and then orange. So I think we can call that feature complete. And to wrap up this section with a quick note on authority, we don't wrap this with an authority check because we actually want the health to change on all representation of the player. If we wrap this with an is authority checked, well then this health change would only change the colors of their health bar on the host peer, but we want it to change on all connected peers, so we allow the signal to run on all connected peers so that the health bar is reflected accurately across all players. And the last thing I want to do in this section is reset the player's health after they've died. And if you remember, back in our attribute component, we had a signal that emits when the player has no health. So let's wire that up. Back in the player script, let's wire up the no health signal to a new function called player no health. In this case, we are going to wrap the signal with an authority check because we don't need this to fire on all peers, just on the host peer. And the reason for that is because we're just going to reset the health. And since health is synchronized across client peers from the host, this doesn't need to run on the other peers. So let's reset the player's health. Create a new function called reset player. And we'll leverage that function to reset the health back to the starting health that we set here. So when the player is down to 0 health, I don't want it to immediately reset. I think this will play better if we give it a 1-second pause between resetting. I think a 1-second cooldown should be enough. And you can see there the player's health has been reset. Now's a good time to commit your working changes before we move on to the next section. So at this point, you can just call it a day. You have a multiplayer setup where you can fly around some game world, you can shoot each other, take damage, and the health will reset, and you can just have fun with that. But I think it would be cool to wrap up things with a game over screen that displays the score, and then after you win, let's say 5 matches, you can restart the match. Let's dive in. First, let's create a component to manage displaying the score on screen. I'm going to name it Scoreboard Component. And let's set the class name. Let's open up the game scene and then add this new node to it. If we have a look at the 2D view, let's create a couple labels to track the player's score. So under the existing game menu panel, let's add a label for player 1 and 2 respectively. So here's the transform properties that I'm going to set for this. And then under theme overrides, I'm going to up the font to 36. And let's duplicate that. And we'll move it to the other side of the view. And while we're in here, let's go ahead and just create a button for when we want to play again. I'm going to set the font size to 72. And we can just center it in the middle of the screen. Great. And for now, let's just hide it. So back in the scoreboard component, let's wire up those labels. So we need a way to figure out how we can keep score and share that across all of the connected clients. There are a few ways to do this, like synchronizing a score field, but I'm going to use RPCs to report the score as needed to the connected clients. And keep in mind, this is a 2-person match, so I'm going to be making some assumptions when designing how this all works out. Let's create a new auto load called Match Manager. Let's go to the project settings, Globals tab. I'm going to move this under the multiplayer directory. Looks good. So I'm going to use the match manager to handle those things that are going to commonly occur during a match. We're going to reset scores or restart a match, what happens when a player leaves a game, and when a player dies, that sort of thing. So right off the bat, I know we're going to need a winning score constant that marks when a player, well, wins the game. So how are we going to keep score? Well, I think when a player dies, we just award the other player a point. So we need to report to the match manager when a player gets 0 health or dies. Let's go to the player script to see what we're going to call that. So when the player reaches no health, which happens within the authority context in this case, which I believe is okay, we'll make a call to the match manager here and pass in the name of the player that just died. So let's build out that function. So to be able to track the player scores, we need a variable to house that data. So I created a dictionary, and I think we're going to use the player's name as the key or the network ID, and then we're just going to set that equal to the score. So for one player, it'll look something like this. But first we need to add the players to this once they join the game so that we can enable scorekeeping. So let's add a function to do that. So we add the player based on their network ID or player name, and then we'll just start their score at 0. And since we're adding players, we should probably also be able to remove players if they disconnect from the game. So let's add that. So now we need to figure out when we're going to add them to scorekeeping. I think we can do this in the spawn manager when we're getting ready to add them to the game. So right before we add them to the spawn path, let's make a call to register them with scorekeeping. And in this game setup, the name is the same as the network ID. And now that I'm thinking about it, I think we should add the call to remove them from scorekeeping if they disconnect from the game. But let's wrap that in a different function in case we want to do some other cleanup when they leave the game. And for now, we're just going to remove the player from scorekeeping, but in the future, you may want to add some additional things here to clean them up when they leave the game. So back in the spawn manager, under peer disconnected, so let's make a call back to the match manager. So after the peer disconnects, we make a call back to the match manager. And that way our players will be cleaned up nice and tidy if they leave the game. So now that we can keep score, let's get back to what happens when a player dies. So we need to loop through our player's score dictionary and find the one that didn't just die and add a point to them. So here we loop through all the players' scores, find the player that wasn't killed, and add a point to their tally. So our score's been updated, but this is only happening on the authority. As if you look back at the player script, player no health happens under the context of the server authority. So once the score is changed, we need a way to report that to the other connected peers. So I think the best way to do this is with an RPC. So let's add an RPC called report score. So since we are operating in the context of an authority, I want to make sure that this RPC can only be called from an authority out to the connected peers to report the score. And that's why I've set the mode to authority here. We're going to add call local because we want the host peer to be able to report scores to itself. And I'm going to add the transfer mode of reliable because we really want to make sure that our scores are reported. So back in our player died function, let's add a call to report the scores. So this will actually call from the host down to the other connected peer, but we still don't have a way to update the scores back in our scoreboard component. So in order to inform the scoreboard component that the scores have been updated on that local client peer, let's create a signal to emit that once the scores are reported, it can update its labels. So let's listen for that signal back in the scoreboard component. And then once we have the scores, let's update the labels. This is going to be a pretty crude approach to updating the player scores. You can see I'm just checking if this is the host player based on their network ID, and then I'm updating the text accordingly. Well, let's create the player 1 label that we can reuse when the scores are updated. And make sure you update it to point to player 2. Let's create another label for player 2. So let's run a demo to make sure the scores are updated when a player is killed. And look at that, you can see the player 1 was been updated on both clients when player 2 was killed. This is working as expected. After the player's health dips below 5, the other player is awarded a point. But now we need to report the winner of the game once one player has reached 5 wins. So let's look back at our player died function in the match manager. And once the player registers a point, let's see if they actually won the game. So I'm going to check against the winning score to see if the player has reached that threshold. So at this point when a player wins, we need to inform everyone that the game has ended. So I think this is a good time to create another RPC for game over. I'm going to use the same RPC configuration as the other RPC because it's the same context, and it's going to accept a winning player name and the final scores. Since I already struggled through setting this up, I realized that passing in the final scores to the game over RPC call is the best way to go rather than reporting the scores like we did earlier. In short, based on the way I have this set up, it just makes sure that we don't overwrite the winning label once the game has ended. So let's add the RPC call with the winner and then the final player scores. So at this point, we can emit the same scores updated signal so that our scoreboard can be updated. And let's create another signal called game ended. And we're going to pass in the winning player name. So let's go back to our scoreboard component and wire up that game ended signal. So when the game is over, I think we'll just add a winning label to the player that won the game. And again, I'm doing that crude check against the network ID of the host. You'll have to come up with something a little better if you have more than 2 players. So all I'm doing here is just tacking on the word winner to the label that we've already created. Genius, isn't it? So at this point, I think we can show the play again button that we created earlier. However, I only want it to show up on the host because I want them to decide whether or not the game continues. Now that we're on the topic of the play again button, let's connect a function to it when it's pressed. And after the button is pressed, we'll just hide it again. Now let's test if our winning label works. Well, it looks like our play again button worked, but it looks like the winning label did not. So you remember earlier when I said I wanted to pass in the final scores instead of reusing the report score RPC? Well, it ended up happening anyways because we still have a call to it right here. So to remedy that, let's just add a return statement here after we found the winner. And look at that, player 1 is our winner. But if we hit play again, we need to restart the actual match. And right now that doesn't happen. So let's go back into the match manager. Let's create a new function called restart match. And in there, we want to reset the scores and also the labels. So we're going to call to a new function called reset scores. So our restart match function will first reset the scores. But where are we actually calling this restart match from? Well, when the player hits play again, I think that's a good place to put it. So back in the scoreboard component, after the player clicks the play again button, let's add the call there. But we still need to reset the score labels. So while we're in here, let's add another function called reset scoreboard. Okay, so we have our utility function to reset the scoreboard. How do we actually tell the scoreboard component to reset it though? Since restart match is only called on the host machine, that means that the scores will only be reset there as well. So we need another RPC call to reset the scores. So let's create another one called play again, and we can reuse the same RPC configuration as the context is the same. But once the play again RPC lands on the other connected client, we need another signal to tell the scoreboard component to update the labels. So let's name it game restarted. And let's not forget to call the play again RPC when restart match is hit. Now we need to connect to the game restarted signal back in our scoreboard component. And we can connect it to our reset scoreboard function that we created a minute ago. Now that I'm thinking about it, I think we need to leverage this game restarted signal in our player script, because not only do we need to reset the player scores, but also the player health. So let's take a look at the player script really quick. If we scroll down, we have this reset player function. So I think it may be a good idea to hit that when the game restarts, because what if the client leaves in the middle of the game and the player's left with only 4 health, like the host machine, and then a new player joins in and that player has full health, but the existing player only has 4 health? Don't you think that we should reset their health? I think it's a good idea for our player to listen to the game restarted, just to be sure that if a new player joins the game, their health will be reset. So let's wire that up. Okay, just going back to the match manager, I'm thinking we got everything working. So let's do a quick demo. All right, so we have our winner. Let's go ahead and click play again. And the player's health and score labels both reset. Now let's test it on the other client. We've got the correct winner label and score. So let's hit play again on the host. And look at that, everything is reset. Perfect. Now, if we look at the example that I was talking about earlier, where the player was at a lower health and then left the game and then rejoined, that'll look something like this. So the host player, he's got like 1 health left, and then this client drops out. I know this might be a bit of an edge case, but I just wanted to handle it for illustrative purposes. So let's say you have the matchmaking and lobby and all that set up to where another player can drop back in this case represented by clicking join game again. The new player has full health, but the host does not. So I think we should be able to reset their health when a new player joins. So how do we do that? Well, I think back in the spawn manager might be a good place to do it. Basically, what we can say is anytime a peer is added through the peer connected method, we can just restart the game. Yeah, it'll run either way if it's a new game or if a player joins halfway through the match, but either way, it just resets the scores. Because if we look back at what restart match does, it resets the scores and hits the play again RPC, and that's going to run on all the connected clients, which emits the game restarted signal. And if we look at where that's used, and then back over in the player script, what we added just a minute ago, it's going to reset the player's health. So I think that's a perfect way to reset the match and make sure if there's a late joining client, their health and scores are all reset. Let's do a quick test to make sure it works. Okay, so their health is pretty low. Player 2 leaves the game. New player joins back in. Score and health is all reset. Looks perfect. And we should just double check that everything is still working. So let's just go through a match really quick. And it looks like things are functioning as expected. So one last thing that may or may not be that important to you is I was thinking about pausing the controls on the inputs and firing the missiles once we get to the play again winner screen. Like right now I can still move around and shoot missiles and all that stuff, but it's still going to take damage and it's probably going to give me a score. Yeah, see, it's moving me up to 6. So there's a few ways to handle this, but basically what I want to do is prevent them from moving or firing in the game once we get to a game over state. So one quick way to handle this is to add a game pause variable to the match manager. So I think the first place we can set the game to pause is when the game is over. But we need to set it on both clients. So since we know the game over RPC calls down to all the connected peers, we can actually update that there. And since the play again RPC will restart the game, I think we can unpause the game safely there. And also because we know this is ran on all the local peers. Okay, so this is where we set the game to be paused or not, but where can we put the checks to make sure the player can't move or fire the weapons? Well, the first place I can think of is the player input. So since we already have this conditional here that makes sure only the local authority is the one that can change the inputs, we should just be able to tack on a check to make sure the game is not paused. So I know this will prevent players from moving or firing a weapon when the game is paused, but I'm a little suspicious that something else might happen. Let's just run the game to see. So I'm firing here and I'm about to kill the player. And okay, so I can't move anywhere, but I can't actually stop moving. So yeah, that's what I was suspicious about. So this is an edge case where your player received an input to move in one direction, and in this case across the screen, but the input will never change because we just wrapped it in a conditional. So your player is just going to continue to move in that same direction because it's never updated. So I think we just need to add another conditional here that says don't keep running the physics process, which moves our player if the game is paused. So regardless if we are moving them or not, let's just make sure they don't move at all. Now let's try that test again. So I'm going to keep moving forward when I fire this last projectile. Let's see if the game prevents me from moving. Yes, and it worked as expected. Excellent. So I think that wraps up this Godot basic multiplayer tutorial. If you've got everything working, now's a good time to make that commit. But what about playing with a friend? Well, I'm going to cover that in a detailed follow-up video, that is, if you're interested, so please let me know in the comments. In short, you can export a client build, share it with a friend that's on the same network, but first make sure you make an update to pass in the local IP of the host computer into the create client function. Or just have your friend pull down the project from GitHub and then make the same changes to point to the host computer. If you want to test out your skills to see where to go from here, try to create a move component that handles all the move functionality, similar how we set up the hit and hurtbox components. Create a tally of wins that shows how many total wins a player has during a game session. Keep players from leaving the bounds of the window. Add sound for ship movement, missile firing, and explosions. We are barely scratching the surface with this effort, but I'm hoping that it helps you better understand one set of networking tools so you can begin your multiplayer journey, to familiarize you with some basic multiplayer concepts through illustrative examples assembled for brevity. I didn't make the whole project out of components, but we dabbled with it to get you used to good design practices. We didn't cover lag compensation, but you've been introduced to authority, a fundamental concept for multiplayer development. We could have probably used a multiplayer synchronizer in the game scene to sync those scores between players, but I wanted to show you how we could leverage signals, an auto load with RPCs, to report the scores from the authority to the connected peers. The point is, there is much to learn, but keep at it and it will eventually click. One stage of your journey is over, another begins. If this video was helpful and you'd like me to continue the series with more in-depth tutorials on using the multiplayer synchronizer and spawner, demonstrating authority, applying lag compensation, or exporting server builds, hosting with Steam, and so on, or any other questions you may have, please let me know, comment below, or drop by the Discord. Thanks for watching.